Kenai Fjords and Lake Clark National Parks. We'll go through how they're connected, the story their rocks tell about past climates, and what we might expect in the future. So up top on the left is a picture from the Kenai Fjords National Park Service page. It shows Harris Bay with Northwestern Glacier seen in the top right and Harding Icefield visible along the top of the photograph. Northwestern Glacier is one of the park's 6 tidewater glaciers and has retreated over 6 kilometers since the 1950s. Up on the right is a picture of Redoubt Volcano from the Lake Clark National Park page. It's one of 2 active volcanoes in the park, the other being called Iliamna Volcano. First, we'll talk about Kenai Fjords, and this is citing info from the General Learn ribbon on the Kenai Fjords National Park Service page. It's a conjunction of sea, mountains, and one of North America's greatest ice masses. The park's nearly 40 glaciers flow from Harding Icefield, and about half of the park is covered in ice today. Those glaciers carved the U-shaped valleys that are now flooded as fjords. This is still a glacial landscape in motion today, and shrinking ice is a visible sign of ongoing climate change. Both of these figures are from the Kenai's Geodiversity Atlas. I won't explain too much of the cross-sectional one on the left, as I believe it's pretty well labeled and simplistic, showing some of the geologic activity. But on the right, I'll contextualize it by saying that beneath the ice, the Chugach Prince William Accretionary Complex exposes pieces of marine sediments from a subducting oceanic plate and welds to the margin of Alaska from the late Cretaceous into early Cenozoic, later sculpted by Pleistocene and Holocene ice. The park's geodiversity entry lists the McHugh Complex, Valdez Group, and Orca Group as key units with younger quaternary glacial and coastal deposits on top. Marine and terrestrial stratigraphy appear in Kenai Fjord's accretionary complex, turbidites, and the quaternary glacial and coastal deposits. Essentially, a subduction foundation was carved into fjords by ice, and that icy top is still evolving. So I did want to say that the 3 main colors you're seeing on the bedrock map, the light green is a Valdez Group metasedimentary rock, undivided, Upper Cretaceous. The gray is thin to thick bedded turbiditic sandstone, siltstone, and shale, and the red is granitic rocks of Harding Icefield region, Eocene and Paleocene, and there we'll be seeing granite, granodiorite, and minor tonalite. And on to Lake Clark. You can see this is an absolutely massive park at over 4 million acres. Most of the parks that I'm talking about are inaccessible. So according to the Lake Clark park homepage and the volcanoes page, both from National Park Service, it lies just across Cook Inlet but represents the other half of the same plate tectonic mechanism that formed Kenai Peninsula. The active volcanic arc above the subduction zone produced the 2 active volcanoes of the area, Redoubt and Iliamna. These form a fire and ice terrain where volcanic steam can be seen in the same region as Salmon Run. The NPS Lake Clark Volcanoes page highlights that both are young stratovolcanoes built of layered lava flows and pyroclastic deposits. Both of these images and the information I'm talking about on this slide are from the Geodiversity Atlas as well as the park's Faults and Fossils pages. Pictured here is the bedrock map of Lake Clark, and to the right is a zoomed-in portion showing both volcanoes. As you can see, it's a very geologically active area with complex composition. Volcanism dominates Lake Clark through its active stratovolcanoes. Basement rocks and orogenies are expressed by accretion, uplift, and faulting on both sides of Cook Inlet. Lake Clark is stitched together by major faults and a mix of Mesozoic and younger rocks uplifted and reworked by ice. The Geodiversity Atlas points out that the 225-kilometer-long Lake Clark Fault records ongoing crustal strain where the Pacific Plate dives beneath Alaska. It also notes quaternary deposits from repeated glaciation, as well as paleontological findings such as Jurassic marine fossils. To speak on some of the connections between the both parks, I'm going to refer to Kenai Fjord's homepage and Ford Estuary pages, as well as Lake Clark's homepage and Geodiversity Introduction pages. So these 2 parks are directly connected, both being proclaimed as national monuments on December 1st, 1978, and redesignated as national parks on December 2nd, 1980, under the Alaska National Interest Lands Conservation Act. According to Geodiversity Atlas Kenai Fjords and Lake Clark's Natural Features and Ecosystem pages, Kenai Fjord's main idea is to maintain the scenic and environmental integrity of the Harding Icefield, its outflowing glaciers, and the coastal fjords and islands. Lake Clark's mission explicitly protects a living wilderness where local people and cultures still depend on the land and water. For both parks, visitation, research, commercial guiding, and subsistence uses are managed within those frameworks. Kenai Fjords records the trench and slope side of a subduction margin, while Lake Clark records the volcanic arc side. Both had Pleistocene glaciations, which left common landforms like cirques, arites, moraines, and deepened valleys. Both of their ecosystems also overlap with the ocean and mountainous high-latitude regions. Kenai Fjords receives rock flour from glacial melt that fuels rich marine food webs, while Lake Clark's rivers and lakes, which formed from retreating ice, support one of the world's greatest salmon runs. To expand on some of those connections between the 2 parks, I'm going to refer to Lake Clark's Glaciers and Glacial Features page, as well as its homepage, and the glacier monitoring page of Kenai. So both parks are already experiencing near-term climate change. Kenai Fjord states that today's shrinking ice bears witness to our changing climate. The park runs glacier monitoring to track icefield and outlet glacier change. Repeat photo and monitoring show outlet glaciers thinning and retreating from the Harding Icefield, lengthening fjords and exposing new tidewater and terrestrial habitat. In Lake Clark, warming will influence glacier mass balance, runoff timing, sediment delivery, which all affect salmon habitat. Over the decades, expect continued net ice loss, shifts in erosion and deposition where meltwater and rock flour concentrate, and ecosystems adjustments linked to water temperature. Of note, I'd say the last connection is that both of these parks are absolutely massive, Kenai being over 500,000 acres and Lake Clark being over 4 million acres. I wish I had time to get into some of the human influence and properly pronounce the names of both of these tribes. The one that starts with a D is associated with Lake Clark, and the one that starts with an S is associated with the Kenai. The one associated with Lake Clark has been there for over 10,000 years, so I would highly recommend reading those pages. But in conclusion, according to the Geodiversity Atlas pages from both parks and the Kenai Fjords and Lake Clark home pages on National Park Service, Kenai Fjords and Lake Clark are two faces of one dynamic system. Subduction built the foundations, volcanism raised peaks to the west, and ice carved into both their modern shapes. Today, glaciers, faults, volcanoes, fjords, lakes, salmon, and people remain entwined. By reading rocks and landforms, fjord sediments, and moraines, and by monitoring today's rapid change, the National Park Service shows how these parks archive past climates and help us anticipate the future of Alaska's coast and mountains. Thank you.